Now, for our last most missed, we're trying to find the perimeter of the rectangle. So we actually need to find the measurements of x and y using this triangle, and then we add up the four sides to get the perimeter. So point of reference is the 35-degree angle. That makes 85 our hypotenuse because it's across from the 90. It makes x the opposite because it's on the opposite side of our angle, and y becomes the adjacent measurement. So now we're using our SOHCAHTOA to identify what we have and what we need to find. Okay, once again, we've got an angle measure, so all the trig functions are in play. We have a hypotenuse, so sine and cosine are in play. And in this case, we actually have to find the opposite and the adjacent. So we're going to use two functions to help solve in this situation. So to solve for the opposite, we're going to use the sine of 35 degrees equals our opposite measurement x over our hypotenuse of 85. So we're going to put that over 1. The sine of 35 is 0.5736 over 1 equals x over 85. And then we cross multiply to get x equals 85 times 0.5736. And we get 48.76. We got a big party going on out in the hallway outside of the classroom here today. And then we've got the cosine of 35 equals the adjacent y over the hypotenuse of 85. So we're going to cross multiply and solve on this one. We've got 0.8192 over 1 equals y over 85. And then we cross multiply to solve for y. So we have 85 times 0.8192. And we get 69.63. Okay, so if we're finding the perimeter to the nearest whole meter, we have y equals a rounded value of 70, x equals a rounded value of 49. So we have 70 plus 70 plus 49 plus 49, and we get a perimeter of 238. Thanks, and have a great day. All right, for our next most missed problem here, we're looking at question number 20 on the assignment. We're finding the missing value, so we have to find the g. We've got our point of reference. Okay, so for our point of reference, we're standing at the angle here. We're going to label based on that. Here is our 90-degree angle. So across from the 25, we've got the opposite. We've got the hypotenuse across from the 90-degree angle, and then we have our adjacent for the third side. Now, we're given the radius, but what we have to do is find the diameter, double the radius, to get our hypotenuse value. Then we start looking at our SOHCAHTOA, seeing what we have and what we're trying to find. Okay, so we have the angle measure, so we can do a sine function, cosine function, tangent function. All those are okay. We have the hypotenuse of 42. And we're trying to find the opposite. Okay, so we want to look at the function that has something at every position, and that would be our sine function. So we need to find the sine of 25 degrees, the sine of our angle, over 1 equals our opposite measurement, g, over the hypotenuse measurement of 42. Next step, turn sine of 25 into its decimal value, 0.4226 over 1 equals g over 42, and then we cross multiply to solve. 42 times 0.4226 and G equals 17.75. Okay, they want us to go to the nearest whole unit, so we've got a 7 here. That's going to round up the 17 to an 18. Okay, for our next most missed, we've got question number 14. And in this problem, if I can get it stretched right, we are looking for a missing side length. So once again, always labeling based on our position. Okay, so where are we in this situation? Excuse me. So now, standing at the 30 degrees, we've always got the hypotenuse across from the 90-degree angle. Okay, we draw our straight line to find our opposite side, and then we have the adjacent side is the only one that's left over. So when we're looking at our SOHCAHTOA, we want to see what we have and what we're trying to find. Since we have the angle measure, all trig functions are possible. Okay, we've got an opposite side, so we can check that off. And the adjacent is what we're trying to find. Okay, so we're trying to find the adjacent side. So now when we look at our three trig functions, we don't have enough here for sine or cosine, but we do have everything that we would need to build a tangent. So we're going to do the tangent of 30 degrees equals the opposite measurement of 20 over the adjacent measurement of A. Now what we want to remember, turn it into a ratio, and then we're going to find our value. The tangent of 30 is 0.5773, and actually it should be a 4 rounded to that fourth decimal place, over 1 equals 20 over A. And then we're going to cross multiply 0.5774, A equals 20, and then based on algebra we're going to divide both sides by 0.5774 to get our measurement for A. And we want to be the nearest whole unit here, so 20 divided by 0.5774 gives us 34.64. So we would round that up based on the 6, and A should be 35. Now, for our next most missed, we've got problem number 11. When we're looking at problem number 11, what we're doing now is we have the ratio, and we're trying to solve for the angle. So what we really want to think about in this situation, when we've got the cosine of angle B equals 0.6, is go back to basic algebra. We want B by itself, so we want to think about the fact that we're dividing by cosine, because that gets B by itself. Now, on our calculator, there is no divide by cosine button, but what we do have is the cosine -1 button. So what that does is that moves the cosine up onto the level of the value of 0.6, and then all we have to do is plug in the 0.6 to that value. So when we do cosine -1 of 0.6, we get an answer of 53.13. So if we're rounding to the nearest degree, our answer here would just be 53 degrees. Now, our next most missed is problem number 8. And when we look at problem number 8, what we have to remember is we're dealing with values on a coordinate plane. So when we have the values on the coordinate plane, we need to remember that the first coordinate is our x value. The x value is the horizontal. So we're going to put the 6 in for the base of the triangle. The second value is the y, which is the vertical. So we can put the 8 in there. And then we actually have the radius of a circle. And if we notice, this point is on the circle. So the hypotenuse is 10. Now, whenever you're dealing with trig, we have to remember step 1 is labeling based on your given position. So if we're standing right here, the hypotenuse never changes. We look across to the opposite side, and then we have the adjacent at the bottom in this diagram. And then we can work on our SOHCAHTOA. SOH, sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So when we want the sine of that angle measure, we're just looking for a ratio here, and we want the ratio of opposite over hypotenuse. So the opposite side is 8, the hypotenuse is 10. For the cosine of the angle, we want the adjacent measurement over the hypotenuse, so we have 6 over 10. And then for our tangent, we need the opposite over adjacent. Opposite is 8, adjacent is 6. Hello, and welcome to the Most Missed Problems for our Right Triangles Unit 3, Lessons 1 and 2, dealing with our sine, cosine, and tangent functions. One of our first most missed was question number 5, so we'll take a quick look at this one. When we're dealing with a problem like this, what we have to remember is the cosine of 52 is a value. So we plug it into our calculator, making sure that you're in degree mode, and you get an answer of 0.6157 rounded to 4 decimal places. We want to make sure we use a lot of decimal places here for accuracy. And that is equal to 19 over x. Now, it doesn't look like a ratio yet, but let's turn it into a ratio by putting that value over 1, because now this allows us to cross multiply. 19 times 1 equals 1, and then we have 0.6157 times x, and then to finish it up, we're going to divide both sides by 0.6157. When we do this, we get x equals 30.859 to 2 decimal places. It would be 86.